So, moving with the objectives of today's session, we'll be talking about data science workflows and how it can be utilized in healthcare machine learning projects. We'll also understand how we translate clinical problems into machine learning tasks while exploring several key processes such as data collection, cleaning, pre-processing, and feature engineering. At the same time, we'll try to identify suitable machine learning and deep learning models for different types of healthcare datasets while gaining clarity on different types of evaluation matrices. It will also highlight some challenges that people may experience while setting up data science principles. So, this will give you a complete overview of how you can integrate data science or analytics into your research practices in the healthcare domain. In past two classes, we have got the foundation of the medical background and the healthcare practices. That was the core application of this particular course. And today we are talking about the technology that we are planning to deploy into the healthcare applications. So, starting with the very basic overview of data science for the complete beginners, we'll just try to understand what are the fundamentals behind data science journey. So, this talks about a multidisciplinary field. Data science is basically a combination of multiple fields, it is not an individual thing. And inside this, we generally have an integration of statistics, mathematics, and computer programming altogether. And of course, along with these three areas, we need domain knowledge as well. That is why, right from the beginning, right from the first day, we are talking about interdisciplinary research over here. Because even if you are from engineering background, as many of you are from that area, you may have good knowledge on the statistics or maybe computer programming, but in order to deploy your applications in the healthcare domain, you need someone with the domain expertise. So that is why we prefer collaborative studies for better outcomes. Or otherwise, the second thing you can do is you can grab domain knowledge by reading various literatures that are already published in this domain. And in the similar manner, if you have domain expertise, if you know your healthcare background very well, you may need some insights from these other categories as well, such as statistics, mathematics, or computer programming. So, when both these areas will merge together, then only some meaningful patterns we can extract from data, and we can have some actionable insights from the real world information that we may be gathering from clinicians, from various healthcare uh, projects or research documents. So it involves a complete cycle of data collection that we have talked about in yesterday's session, that how we collect data on healthcare from different platforms, and then cleaning of that data that we will learn in future classes, and analysis of that data, furthermore modeling, interpretation of your result, and that could ultimately help you with decision making. So we focus on this entire pipeline to lead the decision making process. Moving forward with the core components of data, few of these we have already discussed in the yesterday's session, so I'll not take much time on that. But yes, it is important to mention here that data is the most important and fundamental component of any data science project. Without data, you cannot do anything. So that comes as your most essential element in conducting any of such kind of studies. And when we talk about data, it could be available in variety of forms, as we have discussed yesterday, that we can have structured data, we can have unstructured data, or sometimes even semi-structured data. So that idea we have already taken yesterday, so I'll not go in depth with that because we have that knowledge already. But we need to ensure that data quality is very fine and it has consistency, it is appropriate to work with, and it include all accurate and complete parameters to lead a good model performance. Furthermore, another important component of data science case study include algorithms and statistics. It is important to mention here that several researchers in the past have already designed a variety of algorithms that can help you to identify patterns or make predictions easily. And there are plenty of statistics based principles that help us to understand the variability in data while understanding various significant features, the confidence between the relationship of different variables and inference of specific features available in the data as well. Furthermore, there may be variety of algorithms that can help you to conduct studies on regression, classification. I suppose you remember it from yesterday's session. I have disclosed these key terms in yesterday's session as well. And there are few other details also like clustering, probability modeling, hypothesis testing, and there are many other areas in which researchers can think of working while collecting core components of data science. As we talk about domain expertise as one of the essential elements of data science, the idea behind is to have a real understanding of the field that in our case is healthcare right now because we are mainly focusing on this domain. So it is essential for formulating right problem or hypothesis that you are setting up at initial stage, proper procedures for interpretation of results, and you need to define the clinical relevance of your data as well while ensuring a practical and safe model building process. Right from the first day, we are talking about that in healthcare, development of any application is more critical because here we are dealing with live patients. It is the matter of life and death. So we cannot be lenient with the modeling process. We cannot consider any random technique or any random model to build the final workflow for leading any of the healthcare applications. The preference here is that we have good collaboration of clinicians or healthcare experts so that they can guide us well, or in collaboration, we can work on refined outcomes that are more easy to trust for the real world scenarios. Similarly, there are plenty of tools and technologies that make up essential component of data science. Initially, you need some programming languages. Python and R programming language are widely preferred for leading data science case studies. There are very large number of libraries available in both of these programming areas. However, in Python, there is a massive set of libraries that can be accessed by beginners easily. And in R also, there are a range of libraries that can be accessed for setting up your initial workflows. Some of the popular libraries I can name, they are mainly available in Python platform. They include Pandas, NumPy, Scikit-learn, TensorFlow, and PyTorch. I'll not go in depth with these names right now. Just some glimpse I'm giving you. In the coming sessions, we'll be talking in detail about these libraries. And by the end of this session also, I'll give you little more details about these libraries. But yes, just to know the keywords, because these keywords I'll be using time and again throughout this course. And in different sessions, we'll be talking about how to use these libraries in a programming platform. Furthermore, we need some cloud systems where we can place our data set, or we may need to integrate with hospital information systems or different standards that we can follow for containing data set on the patient details or other hospital operations on which we are conducting our research study. And there are several visualization tools as well that can be utilized to analyze your data and to create charts or maybe graphs, etc., from your real patient data. So for that, the popularly used visualization tools are Tableau, Power BI, and MATLAB and Seaborn. So in this first level course, we will be practically working on Matplotlib and Seaborn. However, these are some advanced level solutions that maybe in some future courses we can talk about. For the deployment task, because when you are setting up some real-time applications, you may need some platforms, and that can be in the form of certain APIs integrated over website. We can talk about Gradeo interface, that is easy to deploy user interface. And other than that, we can have Streamlit or Docker, etc. So things that I have highlighted here, many out of these will be covering in this particular course, and many of them will be taken forward into other courses that will be conducting soon in coming days. So now we are going to understand the difference between few key terms. And here the most essential ones are data science and machine learning, because they will be the core of the course we are conducting right now. And even if you consider about the 3-level course that we are talking with ahead of this foundational course, so they will be mainly focused around data science and machine learning. That are the key terminologies to understand right now. As I told you earlier, that data science, this is a complete end-to-end process to work with the data. It can help you to understand certain hypotheses. It involves several steps for preparing data set and applying models on your real-time data. At the same time, it has some methodologies for evaluation of your results. And at the same time, you can integrate user-friendly solutions for decision making. So everything is incorporated in the single dimension, that is your data science package. So when we talk about a research study being conducted over data science domain, it may include all these types of steps or approaches within. Similarly, machine learning we consider as a part of data science toolkit. When I say data science toolkit, it includes several procedures and methods that are incorporated to achieve your final outcomes in any case study. So this toolkit may also incorporate machine learning for building predictive models or to learn patterns from data for any kind of forecasting. That could be your classification modeling or maybe regression modeling. The next key term list we can have is AI, ML, and DL. These terminologies are widely used in the marketplace these days. Whenever you see people talking something about AI, these terminology you will hear more frequently. So when you are planning to use AI in your any of the research projects, you should be at least familiar with what these terms mean. So the first one, we have AI, that represents artificial intelligence, which is the main universe, or we can say like the broad concept on which there is a very big buzz in the market right now. And it is all about building systems that contain or that are having human-like intelligence. While building AI-based system, the main concept is mimicking human intelligence into some machines. And while working around this, we have some subsets of artificial intelligence. Just two of them I have highlighted here. Otherwise, there are many other subsets of artificial intelligence as well. But the two that are more into focus for this course, as well as in the market these days, they include machine learning and deep learning. So in the first subset, we talk about data-driven algorithms that can learn from data but require a combination of data science with it. As I told you earlier, that data science and machine learning work hand in hand. We need both of them together to deploy models. So this is all data-driven algorithm. First, we need to prepare data, we need to clean data, and then set up machine learning pipeline. However, on the other side, this deep learning model, this is your machine learning based neural network, and it contains several layers that can help you to work around images, speech, or text. So this area, this subset is mainly focused around your unstructured data or unorganized kind of information that you may get from different sources in the healthcare domain, such as your X-ray images, MRIs, CT scans, etc. They are processed with the help of deep learning generally. So currently, if we talk about the current level of the course in which we are working, we'll be mainly focusing on the data science area. Since this is a fundamental course, a very basic level of the course, we'll be mainly focusing on the data science area. And in the second level of this course, because this is a 3-course series, in the second level, we'll be focusing on machine learning. And in the third level, we'll be focusing on deep learning, so that you get a complete package about how this AI domain and data science can be utilized in the healthcare applications. Talking about some real life examples of data science. I'm just taking some examples that many of you may be using in your day to day life just to understand the topic in a better manner. Because when you use things in your day to day life, you can compare it easily. So, the very first thing I can talk about is Google Maps. We all know how important Google Maps have become over the time. We have seen how people are using them for day-to-day traffic estimation, for getting fastest routes to their destinations, and this with time started saving much of our time, and it has become a common practice for everyone to use Google Maps these days. So this is one of the biggest invention over time, we can say, where real-time data is being processed, and there are some predictive algorithms involved in between that can guide you through fastest routes. Sometime you will observe that when you go for some long drives, you may get in the meantime you may get messages on your Google Maps stating that you may find more traffic on this route, there is an alternate route that you can take to save time. That kind of messages keep on appearing on our maps application. So that is how your real time data science and machine learning or AI works. It guides you for better decision making. And similarly, other area we can take is like Amazon or Netflix based recommendations. For instance, you might have observed as a general shopping experience, I can tell you, those who prefer shopping online, whether on Amazon or some other marketplaces, you might have observed that as you purchase something on those platforms, those they keep on guiding you further on what else is relevant to you. Like when you watch certain movie on Netflix, next time you will start getting suggestions stating that you watched this movie, so these other movies may be of your interest. How Netflix know that? Because it is tracking your viewing pattern every time. When you log in into that platform, it starts tracking your interest. Whichever movie, web series, or show you open, it keeps that in its memory list, and then it keeps on updating data based on your interest, and you will get those highlights on your Netflix login account. Same goes with the Amazon. And there are like multiple types of algorithms working behind. I'll give you a better idea. One thing is tracking your personal preferences, like what you have watched earlier, what you have purchased earlier. That is one part. Based on that, it is giving you some regular recommendations. But at the same time, there are some algorithms that are tracking most frequent purchases or most frequent watches on the Netflix. So it is keeping a track of entire population who is available on the platform. So sometime you will observe that if you put maybe bread in your cart while shopping online, the platform will start suggesting that you should buy butter also, because they are commonly purchased pairs. So this is how the AI works behind. It keeps on predicting the need of people based on the patterns that it is observing from the continuously evolving population on it. And same you can see further with ChatGPT or language models. There are several kind of text data sets you can find in healthcare domain. As I told you in yesterday's class also, that there may be doctor summaries, nursing notes, etc., that are available in the form of textual information only. So that human like text we may have for processing some time, and we may need to make certain decisions based on those prescriptions or recommendations from doctors. So for that we need language models. We also call them large language models, sometimes the extended version of those models, that is able to process a huge amount of textual information. They become your large language models. We may discuss about that somewhere in the third level of this course series. There we'll have some discussion over language based models, and as I told you yesterday, natural language processing also will be discussing over there. So this is one common idea. Many of you might be using ChatGPT already. Like, you can put your prompts over there and it can answer your queries like more human language. So that becomes an application of data processing and AI based involvement. And if we talk specifically in the healthcare parallels, there are many applications at initial level that we can consider. For instance, predicting risk of certain disease, or analyzing medical images for faster decision making or diagnosis. Similarly, personalized treatment recommendations we can give, and automatic summarization of clinical notes is also possible. That is with the help of large language models, definitely. So now coming to the types of healthcare data, I'll not go much in depth in this because majority of things we have already discussed about this area in a previous session, but there are few additional things we need to know. So a little bit of glimpse about that we'll have here. First thing, we need to understand that healthcare data is generally unique in comparison to majority other applications, because here we get a diverse and complex information from multiple sources, and your information available may be multimodal. This term is very important here. What we call multimodal is when you have a combination of data which is in different forms, like a combination of text plus, it could involve maybe videos, maybe images. If everything is all together, text, maybe videos, plus maybe images you can have. So that becomes multimodal data, where different modalities are involved. So when you are processing this kind of information, we call it multimodal application. So it will incorporate variety of algorithms in AI domain also to process all this different type of information: text, videos, and images, etc. There may be audio, there may be speech information, maybe some recorded conversations of patients and doctors. There can be any number of formats involved in multimodal data. There are single model data and multimodal data also. Single model is when you are processing just one format, like maybe only text. When you are combining multiple formats, it becomes a multimodal problem. That is generally little complex to perform for a beginner, because first you need to handle single type of data, then you can easily understand how to combine different versions of data together and then proceed with the model building in that. But yes, that is one important application you can consider in healthcare research applications. And every time we are gathering data from real time scenarios, as I told you yesterday, they may be available in different dimensions, different types of uh, presentations may be followed by the doctors or the researchers who are gathering data. So there may be several challenges involved in terms of data collection itself. So yesterday we have talked a little bit about structured data, unstructured data. So I'll not go much in depth on this topic. I'll just take it forward because we know all these things already. Unstructured data also I have highlighted in yesterday's session, like doctor notes or nursing notes, etc. Whatever is written in some textual summary or text heavy document that we may have, that becomes your unstructured data. And there are some specific techniques that we need to process this kind of information. As I told you yesterday, such as NLP models, etc., are commonly used. These are names of some popular NLP models, algorithms we can call. We may discuss that on level 3 course somewhere. These are some extensive models that are already trained to work over textual information so that they can extract relevant insights, maybe symptoms, risk factors, or diagnosis patterns from the text data by understanding actual context of the information presented to them. We have also talked about semi-structured data that may not have any fixed schemas, but they may be sometime in little bit of organized form, like partially organized. So for these kind of data sets, you may find um, some scalable or automated data extraction pipelines already available in the data science domain, so they can be utilized in this area. Now these three things we have discussed in yesterday's session, so I have not gone very in depth into this, but yes, next we have the specific cases also. Like I told you about multimodal data, so what kind type of sources in that we may have. So image data, another popularly used data set where we are doing visual diagnostic. So this may be from some radiology or pathology systems we are generating this type of information, and the examples here may include like X-rays, MRIs, or maybe CT scans, ultrasounds, and variety of areas that you may find in your day-to-day healthcare evaluations, or maybe while checking your patient details. When talking about how this kind of data may be useful in model building or in machine learning or deep learning, etc., we generally need computer vision or deep learning application to process image data. It is not sufficient to have only basic stats models or mathematical models. Rather, we need deep learning principles to deal with image data. And some key applications in this area we can talk about, like detecting pneumonia through some X-ray images, tumors or fractures we may detect, similarly segmenting organs or lesions, etc., or measuring disease severity levels as well. So these visual data patterns are generally invisible for normal human eyes. Like if you are not very much expert in handling X-ray images or MRI images, you cannot tell what they are revealing, what kind of information they may have inside. But such type of tools may somehow help to get more in-depth summaries of those visual data patterns, and that may further assist in diagnostic speed, and it may automate the analysis for the radiologists also, so that timely treatment is possible for the patients. Furthermore, at present, considering the evolution of wearable sensors that we have in the market, at present we may even have IoT sensor data from wearable devices available. Like many of you might be already using smart watches or maybe Fitbit or some fitness trackers with your day-to-day lifestyle. So that is also generating huge amount of data on the fitness level of individuals. So that also becomes an essential thing when you are running some case studies. Several researchers may think of using this kind of wearable sensor data as well to conduct their research studies on regular psychological behavioral pattern or maybe physiological patterns from the day-to-day practices of their target patients. So you may see that in several hospitals also, variety of wearable sensors have been already into use in day-to-day patient monitoring applications. They have started using it. So this basically makes it easier to monitor patient progression with certain disease, and we can have a regular check on how their maybe heart rate or maybe sleep cycles are being modified, and we can keep them under observation. And even the best part is even the remote data access is available with these kind of applications or devices, etc. So this improves healthcare industry very well with the continuous monitoring possibilities. We cannot say that these kind of watches are just for your daily tracking only, with a rigorous workout you want to track. It is not just limited to that. Even for patient health, these kind of watches are very useful because they can give you a regular information about their heart rate, their BP, or maybe their other parameters that are essential for monitoring their health over time. So this kind of information generally generate high velocity constant stream, because if you wear such kind of fit bands or maybe watches, smart watches, etc., they are continuously generating a huge amount of information, or your vitals are continuously being reported into a dedicated application, and from there you can gather this time series data for certain kind of detection or forecasting, etc. So that makes sense for conducting various longitudinal studies easily, because you are able to gather huge amount of data from a set of patients who are wearing those sensors. So some common applications of this type of data we can consider that, like monitoring chronic diseases from patients, or early warning systems we can design for the deterioration of patient health, because we are able to monitor their conditions on the regular basis, and it is easier to make decisions over that data. And similarly, for remote patient monitoring as well, we can utilize these wearable sensors. Then we can have genomic or molecular data as well, that is derived from DNA, RNA, or protein analysis, that may be including whole genome sequencing or maybe gene expression profiles. Sometimes the genetic variants we may be collecting through these sources, and maybe metabolomics, etc. Could be some common areas to work with in your healthcare applications. While I'm discussing about these different types of data sets, they may also help you to trigger into some research applications. If anyone is just beginning with their PhD research or maybe their master level research, and they are looking forward for some intuitive idea to work or to choose as their research topic, so we are discussing several factors on that also here. So that may help you to consider some innovative ideas where you can even merge machine learning or data science principles easily, and you can connect it easily between both domains. So consider it with that point of view also, for those who are looking forward for new research applications on their projects. So in this genomics and molecular data, the relevance of this we can consider for supporting precision medicine, because this can provide you very in-depth detail on how we can monitor patient profiles over different types of diseases, and the impact of different medications we can observe easily. And similarly, it can help us to identify genetic risk of certain diseases, especially some inherited disorders. If we report from some patients, that can assist us to predict the better treatments for those specific type of patients. Similarly, it can be used for drug discovery as well as for personalized treatment pathways, depending upon the complete genetic information of the target patient. However, there are several challenges also involved, like maybe extremely large and high dimensional data you will be getting from this area, because DNA sequence itself generates a huge amount of information that you may have to select very carefully for further modeling. And similarly, you need advanced computational tools to lead with this kind of applications. There is one easier application also to work with, such as claims and insurance data we can consider. And this mainly include financial and administrative data that are connected to various patient services available in the hospital or clinics at a larger scale. It could be useful in maintaining insurance claims or maybe billing codes we can predict easily. For the reimbursement records, also we can need it, or maybe payment patterns or healthcare utilization matrices. In all these areas, you can have vast amount of data being generated from various types of hospitals, and that can help you to understand various factors like maybe healthcare cost, some fraud detections in the insurance claims, or maybe for the resource utilization. And it also helps you to optimize the operations as well as to predict hospital expenses over time, considering how the administrative or financial data is being utilized in that particular premise. One more area we can consider is public health and environmental data, because they also have a very close relationship into your regular healthcare practices. So it could be the data collected on community or population level. And some examples in this area, we can consider maybe the air quality, because this has direct impact on our overall health. We can always see the news about the degrading air quality in several cities, especially maybe the Delhi and Bangalore, etc. We have seen in news over the time from past few months. So the degradation in air quality is directly connected with the respiratory health issues that we can have. So if you are doing some background analysis on patient outcomes, maybe these kind of case studies also you can consider for your research purpose. Similarly, water contamination analysis you can do, and how it is related to progression of certain disease in a specific area. That kind of analysis you can do. And similarly, disease surveillance data you can gather, or maybe some you can have data sets from some reputed organizations such as WHO, CDC, or ICMR, etc. They provide enough amount of information to conduct research studies further using data science applications. And indeed, weather and climate variables are also closely related with human health. So that could be also useful. So I have just highlighted here some areas how all these onsets can help you to set up your relevance in the healthcare domain that we are discussing over here. And for this, it can help you to understand the exposure on patients suffering from asthma, COPD, or maybe some kind of allergies, and even for those who are suffering from some cardiovascular diseases as well. And furthermore, it can help us to support population health models or certain kind of outbreaks. Definitely, we can predict with it, like we have recently suffered from the onset of COVID-19. And in that kind of scenarios, also somewhere this AI based model predictions or maybe some assistive technologies designed with AI and data science can definitely assist doctors, patients, and caregivers at every level. So that kind of overview just we are trying to gather here for setting up new case studies further. Why these data sets matter, that we need to understand very carefully here, because machine learning, AI, or data science, these all these domains are highly dependent on data that we feed into the models. And we know that healthcare keeps on generating massive amount of heterogeneous data every day. They may be processed in variety of ways. Sometimes from certain sources you are getting high volume data, like in the form of images you are getting it, in the form of some documented records you may be getting it. There is high velocity data available from ICU monitors or the real time IoT sensors or wearable devices as well. And there is a variety of information also. So we can call there is 3V, like volume, velocity, and variety. Three things are involved in healthcare dataset, and this leads to a positive outcome for setting up your data science or AI pipelines into healthcare domain, because machine learning depends on large and diverse inputs. More data naturally leads to better prediction accuracies. So this is how data science, AI, and healthcare becomes perfect hand-on-hand solutions for setting up some real-time solutions for the common public, for the experts in that domain. Definitely, we can set up end-to-end insights. We can set up some personalized solutions that can assist the entire chain in this particular domain. So let's talk specifically about how data science can assist in healthcare based on all these details that we have discussed till now. Because healthcare systems are suffering from huge patient volumes these days. There are a large number of chronic diseases that are reported over the years, and we have limited resources. So that is the biggest combination of challenges we have right now. And traditional care models cannot be scaled very fast considering the level of diseases and patient volumes we are having with day. So data science in this scenario can help us to uh, get some reliable tools to analyze patterns of patient data, to predict risk factors, as well as to support clinical decision making so that faster decisions can be taken irrespective of how the burden of disease is increasing on the entire country. And the modern healthcare also is shifting from reactive treatment to proactive and predictive care. That is possible with the association of data science and AI into healthcare domain. So, considering the growing population of the patients and healthcare burden, there is increased life expectancy because more elderly patients with multiple comorbidities are being identified over time. And but at the same time, with this, the number of chronic diseases reported over time are also increasing because the count of diabetes patients, heart disease patients, cancer patients have increased over the years. And similarly, there are plenty of outbreaks that we have suffered from past several years that include COVID-19, dengue, etc. Variety of other stress factors are also associated in our day-to-day practices. So they are all showing us that how hospitals now need to move forward with data driven strategies instead of completely relying on human populations to solve these problems. So, if the healthcare professionals get assistance from the technology, maybe those sudden outbreaks or maybe those increasing burdens of chronic diseases can be dealt better, considering the current challenges that we are facing maybe throughout the world or especially in low and middle income countries. We can report it over the time. At the same time, there is a need for precision and personalized medicine, like because we have observed it over the years, and the medical professionals also uh, have reported multiple times that patients may respond differently to drugs and treatment plans. It is not possible that one size may fit to every patient in the similar manner they may be recovered. That is never possible. So in this scenario, we always have risk in handling those drug doses recommendations or maybe the treatment patterns, because we need to understand how a particular patient is going to respond for specific treatment. And in that situation, data science may help us to do risk stratification based on personal health data of that person. And based on this stratification, we can tailor the drug doses and recommendations very well. And we can even have better treatment decisions so that we can support their life in the long run. And for this, machine learning can help you to combine various genomic data sets, maybe the clinical data and lifestyle factors all together for personalized treatment and medical care that a specific patient may need over time. Similarly, it can also assist us to improve diagnostic accuracy over time because human interpretation over complex data sometimes have limitation. Sometimes the images are of poor quality, sometimes the signals are not appropriately readable, and sometimes the notes are not well translated. There can be several human interpretation errors sometimes, and this may sometimes lead to poor decision making while dealing with patient informations, because we have large number of patients every day. So making more accurate decisions with such type of complex data is always challenging. So in this scenario, at least machine learning based models can somehow detect subtle patterns available in those visual details, and they can provide that information directly to the doctors for better and faster decision making. Like it can help in radiology images, maybe the x-rays, CT scans, or maybe MRIs, etc. Similarly for lesion detection, or maybe for cancer cell identification in pathology images. Everywhere these kind of machine learning models or deep learning models can assist us to improve the speed of diagnosis and definitely the accuracy of treatment as well over time. Furthermore, it can help us to reduce medical errors. That is one of the major preventable mortality worldwide. For the medical errors can be solved somehow by following specific uh, AI-based technologies in between that could otherwise lead to maybe incorrect medication sometime, or missing lab values, etc., can be dealt with very precisely using data science principles, because it can generate automated alerts for any kind of abnormal vitals or lab results that may be otherwise skipped from naked eyes of any uh, person who is not able to evaluate specific values at that particular time, maybe due to missing details in the reports, maybe due to improperly available x-rays or MRIs, etc., due to several reasons. So sometimes this machine learning based support can assist us in better interpretation of lab results. Similarly, some decision support systems can be incorporated into the system, and medication interaction detection can be also done by utilizing these tools, because they can be trained on regular treatment plans or regular data that we are getting from the patients, and accordingly their treatment plans can be improved while reducing any kind of error in the uh, regular checkup or regular treatments of certain patients. Similarly, these technologies can assist us in early disease prediction and prevention as well, because there are plenty of predictive models available in AI domain that can analyze longitudinal data for identifying people that are on risk for certain chronic disease. Like we can utilize this for heart disease risk prediction, or maybe for checking progression of kidney or diabetes. Similarly, for sepsis prediction in ICUs, and readmission prediction of certain patient who may be discharged from ward or maybe from ICU, etc. So all these things we can easily predict by using AI-based applications. So this is going to enable preventive care over the time. And maybe it can reduce the complications and hospitalization chances also for certain patients. And furthermore, if we talk about the general administration management or the resource management, there also data science can assist you better, because hospitals may face variety of challenge like bed availability or staff shortages, or maybe long waiting times are general problems that are faced in day-to-day life. So data science in this scenario can help us in maybe forecasting availability of beds in certain department of a hospital. Maybe load prediction for the emergency department can be done automatically, and the operating room schedules can be maintained by using these specialized tools. And similarly, the supply chain management, which is one of the most essential thing for hospital resource management, because we have several critical onsets over there, so we need to manage drugs, equipments, blood bank, etc. They should be all fine on the regular basis, so that we can treat patients well, especially in the emergency cases. So AI can help us, or data science can help us to lead smoother operations while reducing delays, or even at the same time improving patient experiences throughout the chain. At the same time, we can talk about reducing cost of care, because these predictive models can assist us from preventing any unnecessary tests or maybe avoid duplications, because they can track all relevant details from the existing reports easily. And they can even identify high risk patients at early stage, so that we can treat them on time before they move into the expensive last stage interventions. And similarly, the manual documentation burden can be reduced from the hospital environments. And the insurance analytics become very easy by using AI based tool, and we can see how well it can detect fraud or abuse, etc., in the insurance claims. Similarly, the data-driven decisions become pretty simple to deal with various healthcare expenditures for the patients as well as hospitals by using AI-based models. And one more area we can consider is that it can support doctors in the decision making, because sometimes clinicians face information overload from variety of details, including EHRs, tests, or images, or the summarized notes, etc. So AI can assist them by getting an overview of all these documents all together, so that the a clear summary of everything can be taken, and it can highlight patterns automatically, it can highlight red flags in the reports, and that can help you to prioritize critical cases easily. And while it can even support evidence based treatment options while saving much of your time in entire treatment procedure. So this can be highly beneficial for doctors. Definitely, we are not talking about replacing the experts who are in the healthcare domain, because that is never possible. The experience that doctors have, that is a huge thing that supports the entire community. But to assist their day-to-day practices, somewhere these technologies can definitely assist to speed up the processes and to just remove any critical onsets in the medical domain. Maybe we can take assistance from these technologies. Talking about some real world examples, like if you are looking forward for some specific areas of applications to work with in your research projects, maybe in future, it could be heart disease prediction using machine learning. So in this case, you can train machine learning models on patient vitals. That includes maybe ECG, cholesterol levels, or maybe lifestyle habits of that particular patient. And based on that, it is possible to predict heart attack risk, or maybe some heart disease consequences for certain patient. We can predict ahead of time, and we can prevent certain high risk factors in future, or it can provide some preventive care possibilities for the targeted patients. Similarly, we can talk about diabetic retinopathy or maybe the cancer detection as well. So, for this, several deep learning models can be utilized to classify retinal scans to detect early signs of retinal damage. And at the same time, they can be used to screen camps or maybe rural telemedicines easily to make quick decisions for those who are suffering from certain kind of issues. Similarly, cancer detection, it can follow by analyzing histopathology images directly by using CNN models. I'm not talking in detail about CNN models right now. In upcoming courses, we'll have that information in detail. Or basically, on level 3 course, we'll be talking specifically about CNN networks and how they help to deal with the images, maybe the tumor images, maybe the cancer cell images, etc. How these kind of models assist practically, there will be talking in detail about that. However, I'm giving you a general idea about how in real world this data science and AI applications are working right now, and you can consider them also for any of your research projects further. Similarly, it goes with predictive ICU mortality and patient deterioration as well, like time analysis of ICU vitals. We can do real-time consideration of all the relevant vitals. We can make predictions over mortality risk or maybe sudden deterioration of patient health. We can do that hours in advance so that we can arrange adequate support for that person, or the early intervention decisions, if any required, that also can be done with the help of these predictive models. There are possibilities for IoT based chronic disease monitoring. That is getting common with time in plenty of big hospitals these days. There are heart rate monitors and ECG monitors that can be installed anywhere at patient bedside. even at their home. Some mini machines have been devised over the time that can be deployed at their home, and regular monitoring over their heart rate can be done with those. Similarly, wearable glucose monitors are also available in the market these days that can assist with diabetic patients to gather their data on the regular basis to avoid any kind of critical consequences. You can find smart inhalers for asthma tracking that can also provide regular data as well, to leading different decision making applications or critical alerts, etc., if required for certain caregivers. And furthermore, it can also assist in remote patient monitoring and telemedicine or telehealth, where we can assist or provide treatments to patients who are located at some remote places. And even they can connect to big hospitals or doctors available in the big cities. So that could streamline the entire process of providing better medical facilities at all levels in the entire country. Furthermore, machine learning can be utilized in drug discovery and mental health analysis. It can accelerate identification of drug targets easily, and the molecular behaviors on a very clear cut level can be analyzed with these advanced algorithms, which is otherwise difficult with manual intervention. So some machine learning models can better help this, and they can reduce years over your drug development timelines. So that could be a great benefit into the medical community. We can bring medicines faster to the community, so we can save lives of several patients. Similarly, there are plenty of NLP based models that can help us to do speech pattern analysis, sentiment analysis, or maybe the depression or anxiety risk from specific patients can be analyzed very well by using these text based models, and they can even detect the emotional changes in the patients, and based on the voice signals itself they can give proper recommendations, and they can guide patients when they have to move to the doctors for proper treatment, so that we can save them from any emotional damage or maybe any stressful scenarios in their life. Now, moving forward with the data science workflow, because we have seen all the fundamentals that we need for leading data science applications, we have also talked about how data science can help in a variety of areas in healthcare domain. Now, let us understand what is the main workflow involved in this data science. So, starting with the initials, because we know that it is all about a data set that we can start with at initial stage. So we may need to define some problem of clinical relevance, or based on what type of data we have in hand. And then based on that, we need to build some clinically meaningful and deployable AI solution. That is the core of this entire workflow. So at the very first step, you need to start with problem definition. You need to understand the clinical application as well as the data that you may need for building or providing solution to that particular problem. For instance, you need to identify what specific clinical problem you are focusing upon. That could be diagnosis, that could be risk prediction, or maybe triage monitoring, etc., or maybe some insurance claims, etc. Any area you can think of working in. Then you need to be very careful about who will be using the model, like who is your target base for which you will be designing the solution. Maybe it is for doctors, maybe for the nurses, maybe for technicians or public health workers. Sometimes you can have centralized systems for the hospitals itself. It could be even for patients or caregivers at their home. So there can be several possible models on which you can work while defining your problem initially. Then you need to understand why that problem is important, because you need to have some adequate objectives when you are leading certain research application. It should be able to maybe improve outcomes, maybe early detection of certain disease, maybe it could involve reduction of errors in diagnosis process, or maybe talking about cost reduction, etc. So we can step by step identify our predictor variables, target variables, and the population that we'll be considering for data collection. There are several things that at a very first stage you have to think about. And also be careful about what type of data you will be gathering for your problem definition. Maybe single model data or maybe multi-model data you will be getting, like a combination of images, lab results or signals, etc. Or maybe only lab reports you will be considering. So that will be your initial decision making when you define your problem, and based on that you are going to proceed to the second step, which is data collection, about which we have discussed in yesterday's session also, that there are so many sources for data collection. It could be hospital EHR systems, it could be maybe some doctor notes, maybe reports of the patients. There are plenty of sources, but as I told you that it is generally risky to get real patient data involving the privacy concerns and the personalized information that is present in those data sets. So majority of time it is not possible for doctors or hospitals to share patient data directly for any real application. So in that scenario, you can even find some online sources where medical domain datasets are available for public access. They are provided by some reputed organizations online, so that researchers can work on those open source datasets. Some of the possible options you can have is like Kaggle and NIH datasets that contains a huge information on X-rays, MRIs, CT datasets, etc. So these are common sources. You can directly go to a Kaggle website or NIH website to access these types of datasets. In some future classes, I'll also tell you that how you get these datasets. Today, I'm just introducing these platforms to you, but in some future classes, we'll be definitely going to the specific sources, and from there, I'll tell you how you can get those datasets specifically for your research or even for your learning purpose. Other than this, you can have dataset from WHO also, because they keep on circulating several datasets. But while accessing these different sources of data, always make sure that you are following the privacy and compliances very well. Like in India, it is based on NDHM. They have specified the complete legal procedures, privacy concerns, and compliance, etc. That should be followed while accessing patient information for any research work, and many other restrictions also they have highlighted very well in this. Similarly, you need to ensure that you are doing secure storage of patient information, and you are ensuring de-identification in every bit of data that you are using from the patient. Their personal information should be very well removed. Then only you will be able to proceed further by following NDHM guidelines. And at the same time, make sure you understand data formats very well and how you utilize them further. That also you should know when you are collecting it, because then only you will be making adequate decision about what type of information you should gather. Further, in the next step, you need to talk about data cleaning and pre-processing, because the real world data may be affected with so many problems, such as there may be several missing values. I discussed yesterday also the reason behind missing values in healthcare domain. It could be sometime due to missing visits of the patients on the specific days when they were called by the doctors. Sometimes data entry issues we have, sometimes some other errors are there that lead to missing values. Similarly, sometimes we have duplicate entries. That could be maybe some duplicate scans presented during report collections, or some duplicate EHR entries, etc. And outliers are also possible sometime, like some out of the bound values you are getting due to some erroneous readings, or sometime it could be fluctuations in the real-time sensors, or sometime it is human mistake. And for this, you may need to follow some proven statistical methods that you can utilize to remove specific errors or specific duplicates, etc., or specific outliers out of bound observations. So there are dedicated procedures for all this. Similarly, there are normalization and transformation procedures that you may need to follow for data pre-processing. There are some keywords I'm introducing here, like standardization, scaling, or transformation of variables for leading machine learning pipelines. So all these things are very essential before building any of your machine learning pipeline. This stage is like, we can say, the most important one while setting up any of your machine learning or AI based project. This involves the entire onset of uh, data science behind. There are multiple algorithms, multiple principles that you will be deploying in this process behind. So all these things, although we'll not be discussing them in detail in this course, because many of them will be deployed practically when we go to the level 2 course, because there we'll be doing real time case studies with the data itself. So there we'll be doing complete data pre-processing steps, complete data cleaning steps, etc. And in this foundational course, we'll be working around the basics mainly. So you will definitely learn this in upcoming course that we have attached to this series itself. Then feature engineering makes an important part of this entire process, because you may have real-time data in a variety of forms. Sometimes you have lab features, sometimes you have signals, sometimes you have images or text, etc. From each one of these patterns, you need to generate some relevant variables that are processable into machine learning models. And there are specific formats of data that you may need to create by following feature engineering principles. And there are several statistical approaches, several algorithms already designed by the researchers that we can directly deploy on real world data. So this thing also will be learning in some future sessions, that how you do specific feature engineering on a raw data obtained from the healthcare domain. Furthermore, you will have to do model selection. As I told you right in the beginning, that machine learning comes into data science toolkit also. When we are working on data science process, machine learning comes hand in hand. So at the step 5, once you have transformed all your features, once you have pre-processed your data, you need to select a relevant model to make prediction. There are several classical machine learning tasks that you can perform, maybe regression analysis, classification analysis. This we have discussed in yesterday's session also. Other than this, there are clustering and time series models as well that can be utilized in variety of healthcare domains. Furthermore, for image and video or text-based datasets, we have deep learning. So depending upon what is your initial hypothesis, what is your problem definition, you may need any of these categories to work with in your data. And the selection will be based on your initial problem definition and type of data set in hand. So we will be discussing all these things one by one in our coming sessions. And once you have deployed your any of the machine learning or deep learning models, you may need to evaluate that model as well by using different performance matrices. Like we evaluate any statistical model by using some specific parameters. For AI models also, you have to do the same. So there are plenty of performance matrices that you may use in future, like accuracy, precision, or ROC curves, etc. We will discuss them practically also when we'll be deploying some case studies in future. So it will include some error margins like mean square error, etc., root mean square error. Plenty of things we'll be discussing while deploying real-time case studies. Next, we have one important area here on the step 7, generally explainability and deployment. This area is getting more buzz in the AI domain these days. Few years back, the concept of explainability was missing, but now it is one of the most important area, because what people have observed over the years, that if AI models, especially deep learning models, which are generally called as black box models because they have huge set of layers within, and we don't know how they work inside because there hidden patterns involved in their working. So people used to say that how we can trust on the predictions of AI models or those in-depth deep learning models. That was main challenge, the trust issues on the technology. So with time, researchers have come across the concept of model explainability. Now it is possible to see clearly that how a specific AI model is making prediction. like a complete explanation we can have on what kind of features it has gathered for making decision, what kind of local and global parameters it may have considered, and it enhances the transparency over decision making with a AI model, which ultimately leads to higher clinician trust as well. So this explainability leads to better interpretability of results. And I'll also disclose several factors about explainability when we'll be talking about deep learning in future. In third level of the course series, there will have in-depth knowledge about how this may assist in clinical trust building for any of the AI models. And of course, we'll be talking about deployment of the models as well, because this is essential part in data science pipeline. Even in this first level course, I'll be introducing you with the deployment using Gradio interface. I'll tell you how you can create ready to use interfaces for different types of problems in the health domain. We'll be designing them practically, and you will see how we can set them up for different decision makings. Some basic applications at least we'll start designing right within this course itself, and some advanced applications definitely we will do in upcoming course series with this. So now coming to the challenges in healthcare data science, just some quick idea about what possible challenges you may face in this area. The very first thing, technical challenges. As a researcher, you need to be very careful about missing and inconsistent data or the class imbalance, because there may be some rare diseases for which you may not get enough amount of data. Sometimes you have very small data set and then decision making gets very difficult. Data privacy and security issues are the biggest challenge in the healthcare community, because there are several rules and regulations involved behind accessing patient data. So you have to be very careful about that. And there is a need of very high accuracy. That is one of the biggest thing as a developer or as a researcher you need to keep in mind. Even if you are working on this interdisciplinary research application, you have to keep in mind that low accuracy is not justifiable in the medical domain, because we are dealing with living subjects and we are risking life of patient with the technology in that case. So only high accuracy models can be accepted. And indeed, we need to integrate these systems with the existing pathways that we have in the medical domain. So that should be also a consideration, because it is not possible to evolve entire system in one go. With time, we have to integrate them with the existing systems, and then we may find further options to proceed. And there are ethical challenges as well, like bias in models, transparency issues. Patient consent is always required for leading any kind of uh, data analysis further on real-time information. And similarly, there are regulatory compliances also that you may have to be aware about. So that was all about the data science fundamentals that you need to know for this particular course, or in general for conducting any of your research applications in the area. Now I'm just going to talk about Python fundamentals for data science, because that will be the core focus of this particular course in all coming days of the session. As I told you right in the beginning of today's session, that only this session is the last theoretical session of this course. Tomorrow onwards, everything will be practical, hands-on, everything will do. So I'll expect you all to prefer sitting with a laptop or computer while attending upcoming courses, so that you can perform the code side by side and you can learn it practically. And all the upcoming sessions will be completely interactive. There will be no one-way communication, because we will be doing hands-on, and I'll need continuous interactions from all of you. Like I'll be sharing codes with you, I'll be sharing data with you, and you will be implementing side by side. I'll be assisting you throughout the process, and we'll be having complete interactions in those hands-on sessions throughout the session itself. So I just request you all to sit with your laptops from tomorrow onward, instead of just listening on your mobile phones or tablets, etc., because that will assist you better to implement things very easily on your own, and you will have better confidence on the technology with that. So coming to the Python fundamentals that we need to know for the data science over here. First thing, why we should learn Python for data science. Although right in the beginning, I told you there are multiple programming languages, like the most commonly used ones are Python and R programming that are recommended for data science. And Python is generally recommended at wider scale because it is easy to learn for beginners. I personally recommend it to many beginners. Even school students are also learning Python these days. The reason being, it is like a normal English language kind of programming technique. When we start implementing things from tomorrow onwards, you will see that how easy to remember those syntax are. It is like you are talking to a machine in your general language, and you are able to revise those concepts very easily by considering basic syntax throughout the process. And it contains rich data analysis and machine learning libraries. Some of them I have listed right in the beginning. You might have observed there are long list of libraries available in Python environment. And it can do very excellent numerical operations. There are dedicated libraries for automation and visualization as well. That can help you to deploy your models for real-time analysis very easily. And it is also supported by large scientific and medical communities. Over the years, people have seen great progression in this area, so it gets easier to work with. And at the same time, for specific healthcare domain, Python powers lab data analysis in a easier manner. EHR data can be easily processed here. Disease prediction models are readily available. You can deploy them as it is. Similarly, medical imaging workflows are also available, and they can be deployed for research automation as well as for dashboard designing easily. So that a complete system you can set up in the healthcare environment anywhere, and it can be a ready to use solution for any user, whether it is the healthcare employees or maybe doctors or maybe patients or caregivers. Anyone can use those dashboards easily. So as a beginner, what you may need to learn from Python environment, Python is one simple programming language that contains variety of syntax and variables. So from tomorrow onwards, we will start with these fundamentals, because this is the fundamental level course on data science using Python, the first level course that we have in this 3-level series. So this will be focusing on the very basics. Python fundamentals will be focusing on here. In the next levels, we'll be integrating that your machine learning and deep learning concepts. But without knowing these initial details, you will not be able to proceed further. That is why this beginner level course we have started initially, so that everyone who is interested to use data science AI in healthcare, they can at least brush up their fundamentals first, so that it gets easier to move forward on the higher level case studies or real-time implementations on healthcare datasets. So from tomorrow onwards, we'll start learning about Python syntax and variables. We will see how we create variables, specific data elements, or how we deal with the different types of data that you may have in your real patient informations, and how we can rename specific data files without requiring manual entry, how with the help of code we can do everything. That makes easier the entire process. That we'll be learning further. And similarly, data structures will be understanding, and their usefulness in your day-to-day practices also we will learn, that how these lists, dictionaries, etc. can help you to store lab values or patient records, etc. and how they can assist in easy processing of parameters. Everything will be highlighting further. Then we'll also learn about conditional statements, how they can be utilized for threshold detection or specific alerts in patient data. That practically will be implementing with some short codes that are easier to digest for any beginner. Similarly, loops, we can understand that if we have a huge amount of patient information, how we can iterate over data set to gather specific details or specific patient rows if we want to grab from certain huge data set, how we can do that easily by using some simple code syntax that we'll be learning. Then further, the functions and file handling we'll be talking about, some reusable code blocks if we have to set up, or we have to make easier workflows in Python, that will be learning further with some easy to deploy pipelines. We'll be learning that. And moving forward with the error handling, because this is definitely one of the most important part when as a beginner you are learning any of the programming technique. you need to understand how do we handle errors in that particular domain. So I'll be guiding you through that process also. How you identify errors, how you correct them, how you improve your codes. We'll be talking about all those things. So how all these things that we are going to learn further in upcoming sessions, how they are going to help you in healthcare domain. First of all, the variables will be learning. So they can assist you to store vitals, lab values, or risk scores, etc. from the patients. Just few highlights only I'm giving. Otherwise, there is a very big dimension behind that works. There is a very huge number of applications for every concept here. Then for the list, it can help you to understand or store patient level time series values. Like if you are gathering patient temperature details from ward visits, maybe if he is admitted for 1 week or 2 weeks. So every day you may be having some record. You can put that directly in a list for any further analysis. Similarly, dictionaries can be utilized for storing structured patient data, the like entire information, including name, age, lab records, progression over disease, that can be placed in the dictionaries directly. Then loops can help us to process through every row of the data set. And for detecting any abnormal lab vitals, we can use conditional statements. And further functions can assist in clinical calculations. I'll show that with the help of simple codes, that how you can do these calculations easily. And ultimately, we'll be learning about file handling as well, while importing lab, EHR, CSV, etc. into analysis pipeline directly. So there will be also several libraries incorporated into our discussion. First, talking about level 1 course that we are on right now. In level 1 course, all these 3-4 libraries will try to cover. If you see the day-wise schedule also for this particular course, we will learn NumPy library, we will learn Pandas library, Matplot and Seaborn also. We have dedicated days for them. It will help you to learn how we can conduct specific numerical operations on patient vitals. Like maybe different types of lab values, how we can analyze them by using NumPy. Will not go in depth with image processing or ECG signals, etc., because this is the foundational course. But yes, with basic vitals and lab values we'll be considering here, and the higher level signals we'll be considering in upcoming courses. Furthermore, Pandas will be utilizing to deal directly with CSV or Excel files, so that if any EHR data sets or lab results or patient tables we have, we can process them directly. So from the scratch, we'll be learning that part, and that makes a useful tool for your data science operations. For the visualization, for plotting different types of charts, trends, or lab distributions, or to do disease comparisons between different patient values, we'll be learning the plotting techniques with Matplot and Seaborn. So these are some keywords that in future I'll be using. And in this today's session, I'm just highlighting all those keywords that will be of great importance in coming days for all of you. And we'll be definitely using it time and again to learn further and to get in depth with each one of these keywords. On the next level, for instance, if we talk about level 2 of the study that you may need for any kind of healthcare analysis, that includes your scikit-learn, SciPy, and STARS models. So some of these libraries will be learning during level 2 further. So building real case studies, setting up machine learning algorithms, classification, regression, clustering, etc. In-depth knowledge on these libraries will be getting further, and we'll be setting up real world case studies as well for prediction of certain diseases. We'll be using some publicly available data sets directly, and we will learn from scratch how to process them and how to use them for decision making. Similarly, some SciPy library observations, StatsMod observations we can do for running statistical tests on data to understand the modeling principles, etc. So these are another set of important libraries that you may need to know as data science engineer to work into any domain, especially in the healthcare domain further. The last set of libraries that we will be discussing preferably in level 3 of the course further. That is specifically for the deep learning and multimodal data, basically. So we'll be talking about TensorFlow and PyTorch, OpenCV, similarly NLTK or SPACY, that are specifically for natural language processing, as many of you in yesterday's session were interested about dealing with direct notes or textual information. So NLP libraries will be studying about that in future. OpenCV applications will be considering for handling various type of radiology or pathology images. And similarly, TensorFlow and PyTorch will be talking about to handle various types of lab reports or results of the patients directly. So all these libraries will help you to build real life models for setting up healthcare pipelines to assist the people involved in this specific and more important community of our country, or for any country, because healthcare professionals are like the biggest support system for everywhere. And if the technologies can be well integrated for their day-to-day routine operations, we can have better outcomes over time, and we can even reduce burdens on their day-to-day practices. So for that reason only, we are learning to integrate this entire thing together, and it can help you to understand well on the topic and the collaboration of these different technology into the single line of understanding. Furthermore, how these libraries that I discussed till now, if you have to just compare them directly with the healthcare applications that I have listed in different onsets previously, you can see NumPy, Pandas, etc. We can highlight their usefulness. Similarly, for lab and vital visualization, we can use Matplotlib and Seaborn alternatively. Then scikit-learn can assist with the prediction levels, TensorFlow, etc. for medical imaging analysis, SciPy for biosignal analysis, and NLP for textual data extraction from medical records. So these are just case on mapping I have done here so that you can understand easily that what are the benefits of learning all these things that I have discussed till now. So that will give you a better idea of why we are doing all this technological analysis over here. So we have discussed several factors till now, and I'll come to a summary for the theoretical discussion that we have done till now. And after this, I'll take you to the Python setup also, that on which tool we'll be working in upcoming days. Like from tomorrow onwards, everything will be hands-on. So I'll be also demonstrating what tool we'll be using further. A quick demonstration of that I'll help you all with. So what we have discussed till now is like how data science is going to play an important role in modern healthcare challenges. We have also learned about what diverse range of data sets you may find in the domain and how they can be utilized in machine learning pipelines. We have also understood the systematic workflow for any data science project that includes multiple stages, and I have given you different ideas on how different Python libraries can assist you at each one of these stages. And we have also understood about what different modeling possibilities are there with deep learning and machine learning, and how successful deployment of this kind of technology can assist us with adequate clinical practices and to lead some actionable solutions for doctors and patients as well. So this is the main crux of all the theoretical discussion that we have done till now. I'll be definitely taking your queries also on this further. But before that, I suppose that we can discuss about the platform once that we will be using for the analysis in coming sessions. So I'll be introducing you all to an online platform. You will be happy to hear that you need not to install anything on your computers to work from tomorrow onwards, since we'll be doing hands-on operation. But I'll not suggest you to download any of the heavy softwares, because we have a cloud-based solution directly available that any of you can access. Just you need internet connection and your Gmail account, email ID for the login only. Two things you need to work with it. So from tomorrow onwards, what tool we will be using for building all the case studies or all the Python-based understanding, that is Google Colab. That is a online data analytics and machine learning tool for Python programming, and it is powered by Google itself. So they provide you free access of this tool. As a beginner, you can access everything over there freely. And it is enough for starting with basic modelings until and unless you have to do very heavy models. In that case, only you need paid versions of TPUs or GPUs, etc., that offer you extensive memory. But generally, for machine learning model building and for basic data science projects, the free version goes well. So throughout this course, I'll be using the free version of Google Colab only, and all of you will be able to do that easily. So how you can find Google Colab? Because from tomorrow onwards, you will be doing it yourself right in the beginning of the session. Definitely, I'm here to guide you, but still, you need to understand what you have to search for. Like I'll be inserting here Google Colab, or you can search for Google Colaboratory. Both options are fine. So you just have to click on this, and it will take you to the official platform. This Google Colab you will find. Just click on this, and you will be taken to this window. And here you have to observe that on the top of this screen, on this top right corner, I have already logged in because I'm working from my personal computer here, and that already contains my Google login. If you are also working from your personal computer, this will take your login automatically. But if it is already not logged in, you may need to insert your account details, preferably your Gmail account, I would recommend, because that will help you in better storage, because Gmail and this Colab is powered from Google itself. So it will be a better integration to store your data in the long run. So what you have to do, if you can find your account details directly in this right side portion, that will be fine. If not, if you are getting a sign in option here, in that case, you have to click on sign in, and you will be able to enter your account details, your email, etc., to log in here. First, you can quickly let me know in the chat box if you are able to reach to this platform, if you are able to open this Google Colab, and if you are able to log into this. You can quickly post in the chat box. I can see that. If anyone is trying this side by side. You can even open this Google Colab from your mobile phone or your tablet, etc., because this is a cloud solution. So anyone can open it from anywhere. But better for learning, I would recommend you from tomorrow onwards, prefer a widescreen, at least laptop or computer, something, so that you can visualize things very well. I can see only one. Yeah, I can see multiple replies now. Thank you very much for responding. So login you have to do from tomorrow onwards. The same platform will be using. This is for the coding. All the coding we'll be doing on this only. Now, once you have logged in, after that, what you have to do is observe very carefully on your screen. After login, you will have to go to the file option right here. I'm taking it slow so that any beginner can understand it well. You have a file option right here. You just have to click on it, and then because you have already logged in to your Gmail account, it will give you an option to open new notebook in Drive, because it will directly establish connection to your Gmail Drive where it can store all your coding sheets, so that you need not to save them separately. Rather, you can access them anytime from anywhere using your Drive access, because that will be easily available. So whatever coding you will do from tomorrow onwards with me, like we will be doing all hands-on, that will be saved automatically in your Drive, and in future you can access that from your Drive anytime. So what you have to do is click on this new notebook in Drive, and it will open a new window. That will be the basic sheet on which we'll be doing the coding. So those who are going to do Python programming for the first time, this is the easiest, most solution you will have, because you need not to deal with any software. You need not to mess with any kind of installation. You just need your Gmail account and internet, and you are all set for Python programming. So this is your programming sheet. Let me know quickly in the chat box if you are able to open something like this. Just one difference you may have, this untitled may be untitled 0 in your case if you are opening Google Colab for the first time. Otherwise, rest all should be same on your platform as well. Yeah, untitled 0 you will get, because in my case I have so many sheets already opened here. So in my case this is showing certain number because you are opening it for the first time. So the name it is doing automatically 0 1 2 3, it will be doing based on that. So I hope others are also able to open this. If I need to repeat anything, you can let me know in the chat box quickly. If anyone is not aware how to open this sheet, I can repeat that again. You can let me know in the chat box. This procedure you may have to follow every day from tomorrow onwards. So that is why I'm trying to discuss it in very detail, because I suppose that majority of you might be beginners with Python or Colab. So this is important to learn at the stage. Okay, great. I can see few responses and I suppose others are also able to do the same. Now, next thing we need to understand here, whenever you open this kind of sheet from tomorrow onwards, whenever you will be opening this type of sheet, the very first thing you have to do is just rename this portion. You have to rename it with the specific name that you want, like maybe whatever you can remember for future or whatever you feel easier to store. Means you have to create a file of your choice, your name you have to put up. Observe here, I'm just changing this portion, not this extension. This extension is essential as a Python file because this will help you to recognize that this is a Python executable file. This is the extension of raw Python file, basically IPyNB we call it. This is basically Python notebook. So IPyNB extension it has. But yes, this portion you can rename. Like maybe when I start with tomorrow's session, so maybe based on your requirement, you can type maybe Python fundamentals for this. So maybe in tomorrow's session, you will be learning Python fundamentals or any name that you wish that this I can remember for future and I can find my file easily with this. You can give that name over here. So just that untitled thing you have to remove. And why I'm suggesting this? Because in future, this file will be saved in your drive. And when you have to find it for revision or for following up with what we have studied in this particular course, you may need to find those files with specific name, because untitled name will not guide you well. You will not be able to understand which file I need to open. So better to rename it with a easy to identify name, so that in future whenever you have to find this file, it will be available in your drive directly. So you can observe, if I show you this in my drive directly, we will have certain file of this type. Now this one you can see, Python fundamentals file I can see in my drive right now. So this will be readily available. Now anytime in future you can open up this. Now the next thing, once you have renamed your file, what further details you need to know about this platform? There will be two types of cells. Understand this very carefully, everyone, because this I'll be using repeatedly from tomorrow onwards. These keywords I'll be using repeatedly. There are two types of cells. When I call it a cell, I talk about this highlighted portion. This is a cell. Technically, we call it a cell. And there can be two types of cells, code cell and text cell. So here you have options to add these cells. Code cell and text cell you can add from here. As I hover over this, you can also see it suggests options that what you are doing with it, that you can observe. Now, what is the purpose of both of these, especially for those who are doing it for the first time? Understand carefully. Whenever I have to write a Python executable syntax, means a certain code of Python programming, we will use that with the code cell. We will need code cell for that. And if I have to put some reference information, some textual information, or some like step details, or maybe some general information for your understanding, or maybe some headings, etc., to organize my file, I will use text cell in that case. So understand carefully again. Executable codes, I can put only in the code cells, or any supporting information that is not to be executed or for which will not have Python syntax specifically, that we can put in text cell. And in order to insert them, see, there are different options. Either I can click on this text cell plus or code cell plus, and in sequence they will be inserted on my this screen. This is one option. From here, from the top, you can click on any of these and accordingly those cells will be inserted. And you can observe the difference between both. The code cells have a play button in front of them and they appear like this. When I go to this, a play button in front of this, and I can write my Python code inside. The text cells appear like this. We can double click on this and we can write something with this kind of textual setting. And it is possible to take these cells up and down. Observe carefully again. Here I have some arrows. To take these cells up and down, like I can hit on this arrow and it will go up. Similarly, I can click on this up arrow and this will go up. If I need to take anything downwards, I can click on this and it will go down. Let me know if you are able to do this, because time and again you will be doing these kind of things to organize your sheets in future. Let me know quickly if you are able to understand about both these cells. I can see responses in the chat box if anyone wants to respond so that I can come to know if it is going fine on the other side. Yeah, great. You got the code and text cell. So these only will be using from tomorrow onwards. And note here one more thing, that one option is to insert these cells from here. Other option is if you hover anywhere in the middle here between these cells, then also you find option to insert code and text cells. And one more thing, if I click on this, it will be inserted right in the middle. Wherever I click on this, it will be inserted at that position. And on the other side, if I take it from here, it will be inserted right next to current active cell. Like this is my current active cell. If I click on text from here, it will be inserted after this only. If I put my cursor on the end, then I click on code cell. So code cell will be inserted after this only. So this is how we can organize our cells over here. So maybe if I have to give you any instruction, any step or any reference, I'll be writing here like maybe basics of variables, like something like this I'll write. And then here I'll start writing my Python codes. In this section, I'll be writing my Python codes. So you will have a play button in the section where we write Python codes. So in this way, for all coming sessions, we'll be organizing our sheets so that they are easier to read, they are easier to execute and understand for all the beginners. Let me know if the environment is clear to everyone. There is not much to mess with this environment as a beginner. Initially, we will start only with these things. And with time, I'll tell you what other things you may need to use here. So that we will learn with time. But for first 4 or 5 days, we need only this fundamental knowledge of the platform only. Let me know if we are good with this. Yes, if you want to remove any cell, then also it is fine. Like I can go to that cell. Maybe I want to remove this one. So I have this delete button here. Just you go take your cursor to that cell and click on this delete. It will be removed. Similarly, I can go to this, click on this delete. And for every cell, we have this option right here. And along with this, you can find it always displays the keyboard shortcuts also, like Control plus MD. If you press that, it will be doing the same operation. For all activities, it will display the keyboard options also, keyboard shortcuts also. So if anyone finds keyboard shortcuts easier to use, that also you can learn side by side. Otherwise, you have direct options on the screen. You can just click on that and all the tasks will be done. So both ways it is possible. If you are friendly with keyboard shortcuts, you can go do that. Otherwise, with direct click also, you can do the same thing. Let me know if you are good with the platform. this is the easiest, most platform that any beginner can use. That is why I have selected this instead of asking you to install any software on your system. Okay, so this is all regarding the platform or Python setup that we need to know for now. And I'll get back to this Zoom platform. I'll stop sharing my screen since we are already on the verge of session. I'll not take it any further. I'll just open this house for any kind of queries, feedbacks, or discussions on today's session. You can post either in the chat box or anything you have to ask. Maybe you can turn on your mic as well. So till this date, we have done all the theoretical discussions on the topic, and be ready with your laptops or computers from tomorrow onwards to do everything practically, because everything will be hands-on from tomorrow onward. And I'll be continuously interacting with all of you from tomorrow's session onward, so that I can get your feedbacks side by side, whether you are able to implement codes or not, because that will be complete practical oriented, and I need to know whether you are able to do the same side by side or not. So we'll have complete interactions in coming sessions for that. And doing it side by side will definitely raise your confidence instead of just looking at the screen. So make sure you execute side by side with me from tomorrow onwards. Clustering and probability models, I'll try to touch about this in level 2 course. On level 1, we are doing the fundamentals of Python only, because many of the students are complete beginners that we are connected here. So if you just look at the course structure also, I suppose you have all 3 level course series plan also with you. If anyone doesn't have, we can share that again in the WhatsApp group as well. So we have structured it in such a manner that we can start with the very fundamentals, because we had special requests from several students earlier that we need to learn very basic fundamentals first, and then only we can move to the higher end. Level 2 course dates will try to announce by the end of this ongoing course. And we will definitely like to take your feedbacks also, that when you want level 2 course, if you have any specific date requirements or maybe any preferred time durations, we can consider that also, no problem. Preferably, we will have a gap of 10-15 days between both levels. And after that, we can launch the level 2 course. And accordingly, level 3 course will be proceeding further. Yeah, we can work on MRI images, X-ray images also in level 3 course. That is a part of level 3 series. In that, we'll be talking about image processing and text processing directly. So there I can take some examples on MRI and X-ray images to help you understand how we proceed with it. Continuous, it is not always possible, because already this is a 10-day series, and for everyone it will not be possible to organize like their entire schedule for 30 days to attend daily evening classes. So that is why we are keeping a little bit of break in between, and we are sharing videos also for that purpose, so that you can revise concept within that level breaks, and you can brush up all your concepts, and you can have a perfect hands-on with your practical experiences, and then you can get ready for the level 2 course easily. So that is why that gap is given in between. Yeah, that time duration definitely we can consider in coming days. Maybe if 6:30 is more suitable for everyone, we can consider that also. That is not an issue. Timing we can reconsider. Any other queries or any details, if anyone has, they can update in the chat box. Okay, I'll just suppose that this the first 3 days of the course helped us we all to build the foundation for the course, and I suppose that all of you could at least understand how AI and Python, etc., we can integrate together, and how it can help us to set up real-time analysis in future. So the foundational things we have done in first 3 days, and I hope to meet you all again tomorrow at 6. so that we can start on time, and we will be definitely learning the practical hands-on. And I'll request you all to be on time from tomorrow onwards, because we'll be doing practical, and if you miss the starting point, you will be missing everything further also. So try to be on time, and so that you can do everything practically in that case.